the JPA provider. So what is the meaning of that? Whenever the entity class is loaded, okay, then whatever the named queries are defined, okay, all those named queries are first compiled in the database, and when you run the method, it is going to execute many times. So how we can understand this point is, see, I'll explain that what is the meaning of pre-compilation. Suppose, for example, you are writing a query like this. Just understand about what is pre-compilation. Let's understand about what is pre-compilation. Actually, consider that you want to write a query and your query looks like this. Select, okay, or it could be select or insert anything. Select, otherwise insert into, for example, student, then values, student ID, okay, student name, and his marks. Just a simple query. Okay, if you execute this type of query in database, this query will be first compiled.
Hello.
Then the query gets executed. This query is compiled and executed in database. This query will be compiled, then executed. Okay. When you write like this, the query is what? Compiled and also executed. Suppose if you want to execute the same query but with different values, insert into student values 102 B 600. Again, this query is also what happens here, it is compiled and executed. So every query will be first compiled and then executed. Every query will be first compiled and then executed. See, actually these two are similar, same query, but only values are different in the query. First time when you run this query, compiled, executed. When you run the second query, again it is compiled and executed. Means what? Every time it is compiled, executed. Only what are different in between the two queries? Values are different. In query the values are different, but query is same. But still what is happening? It is compiled and executed. Now I am writing something like this. Insert into student values question mark comma question mark comma question mark. Now what will happen in this case now? What will happen in this case? In this case, the query is compiled but not executed, only query is compiled. Now once it is compiled, now you set the values. Now you set the values to first parameter, second parameter, third parameter, you set the values. You set the values, execute. Right? You set the values, execute. Again it is not compiled. Compiled for one time only. Again what you can do? Set the values, execute. Okay? Next. Again you set the values and execute. That's it. Set the values, then execute. So what you are understanding with this? What is the final understanding of this? What is the takeaway from here? The takeaway point is, the query is compiled only once. Now you set the values and execute. You set the values, execute, set the values, execute, because query is same query, only what are going to be different? Values are going to be different, okay? The query is pre-compiled. This concept is called pre-compilation. This is called pre-compilation. That is the advantage of prepared statement. This is all JDBC concepts. This is called pre-compilation. You can set the values, execute. You can set the values, execute. You can set the values and execute. How many times you want to set the values, that depends on your code. As many times that you want. You set the value and execute. You set the value, execute. Set the value, execute. Set the value. This is how this named queries concept will work. Okay. So the difference between other query and this query is what? The query is getting pre-compiled, and now you can set the values and execute the same query for multiple times. You write a loop. For example, I starts from 1, I ends at 50, increment I. Now set the values and execute. Loop repeats for 50 times. Now 50 times query executes, but query is not compiled. How many times the query is getting compiled? The query is compiled for only once, and the same query you can execute for any number of times. This is called pre-compiling the query. Okay. This is the meaning called pre-compiling. That statement is included in my document. So go through this. Okay. Now, like named query, we also have named native query. So what are all the annotations you know is, one is named query, next one is named native query. Native query is also there. Okay. Next, you can define multiple named queries or named native queries at entity class level. What is the naming convention to be followed to provide the name to the query? Entity class name dot method name. And I told you the reason like why entity class name dot method name is required. You can go through these notes because it's already explained to you, and even not only explanation, I have given a diagram here. Suppose, for example, you have created one entity class called customer, other entity class called order, but you have given the same name find all and find all. Okay, here also you made find all the name. Here also you made the name called what? Find all. But what JPA will do? JPA will store all these named queries. You write maybe on customer entity class, or maybe you have written on order entity class, or maybe on some other entity class, doesn't matter. But JPA will store all these named queries in one place. At which place? Persistence context object. Persistence context object. It will store there. How it is going to store the queries? Based on their names. What's the name here? Find all. What's the name here? Find all. Find all. Find all. The second query will override the first one. Gone. The first query is gone. The second query will be there. Okay, that's why we have to follow the naming conventions. That is a point I told in the last session. So you can go through this. Okay. Suppose if you provide the name like this, order dot find order, something like that. Order is an entity class. So entity class name dot find orders, the method name. If you follow this naming syntax, then what happens now? In the persistence context, the queries are not going to be overridden one by other. So that's why it is recommended, and it is a naming convention given that what you write the class name as entity class name dot method name. That's a syntax to be followed. So like named query, what's another one I told? Named native query. This is for SQL query. Define what query? SQL query. And what are the three attributes here? First one is name. Next one is query. Next one is result class. It is extra. One extra attribute. I mean, one more additional attribute is required for this annotation. Which annotation? named query. This annotation should native query should contain one more additional attribute called what? Result class. What is the result class I have written here? Entity class name dot class. If your entity class name is order, then what should I write? Order dot class. Order dot class. Like that I should write. Okay? That's called result class. Now we can see, just for example. Now you try to look at this entity class. Here my entity class name is order. This is a named query. This is named native query. The two annotations are visible to you. Okay, one is named query, next one is named native query. Okay, right? Just I've written example. This is SQL query. Select star from orders means SQL query. Select O from order O means it is a JPQL query. By looking at the query, we can understand is it a JPQL query or is it an SQL query. If it is an SQL query, then what is the annotation to be used? Named native query. And what is the additional attribute to write? Result class. What is the result class we are writing? Order dot class. Okay, entity class name dot class is a syntax. What is the syntax? Entity class name dot class. Okay, enough. This is all we have discussed in the last. Today we want to start with a new topic in JPA. Now, for example, you are doing a transaction. You are doing a transaction, or you are registering for something like this. I am talking about for example. Right. For example, you are doing some transaction. Okay. Tell me, once your transaction is completed, system will generate one ID, na? That is called what ID you are calling? Transaction ID. This transaction ID, a user is going to provide while doing the transaction, or system will generate the ID? System. Transaction ID will be generated automatically by the system. Transaction ID will be automatically generated by the system. This is called what ID? Transaction ID. Let's say for example, I'm talking about example. Example, you are applying for some exam. You are applying for some exam. Could be some exam, any exam that you can say. You are applying for UPSC exam, railway board exam, okay, or any competitive exam like JEE exams, IIT exams, something like that, GATE exam like that. So for your application in online, when you are applying the application, when you are filling the application form, then tell me, for your application there is one number generated, application number. Application number, are you providing it or will be automatically generated by the system? Yes, will be generated by the system. Application number generated by the system. That you are giving an order in online order. Tell me, in online order ID will be generated. Tell me, order ID, are you providing the order ID while giving the order? Do you have any checkbox or text box like enter your order number, then submit the order? Not like that, na? Okay, you submit your order, you place your order, then what will be generated? Order ID. So order ID will be generated by the system. So transaction ID, application number, order ID, these are all automatically generated by the system. You are not giving the input. You are not providing the input, right? Okay. So which means in our entity classes, suppose you have order ID. So in our previous example, what happened is, before we save an order to the database, before we are going to save an order in database, we are setting what order ID? We are setting the order ID, we are setting the remaining data like order date. Then what? What is the next one we set? Amount. Next one, status. So who is setting the order ID in the last example? Just we are learning JPA. We are a learner. So first initially we want to set by manually. So we are setting the order ID, some number we are setting order ID number 20847, something like that. Okay, then we are setting some order date, amount and status. Then we are going to insert the report. We are going to save the order. But actually, if you come to the real scenario, in the real scenario, order ID will be generated by the system. Which means before or while persisting the object in database, the primary key value, order ID is a primary key value only, na? ID value we can call it, right? Very good. The ID value will be automatically generated. ID value is automatically generated. You are not setting the ID. Oh, correct. Suppose you are going to fill a form. After once you fill the form and submit the form, one ID number gets generated. Oh, correct. Sometimes you get a message, this is the ID. Okay, please keep it with you for future references, something like that you are getting on the websites, right? Good. So that is called ID. That ID manually entered by the user or generated by the system? Generated by the system. Even programmer also not going to enter that ID number, right? ID automatically generated by the system. Similarly, now today what we are discussing, how to generate this ID automatically while saving the entity in the database. For that, there are some JPA has provided a concept called as ID generators. What is given? ID generators. We are discussing about ID generators in JPA. ID generators in JPA. Very simple. We'll discuss one by one. Okay. ID generators. JPA has provided some strategies. Okay. JPA has provided what? Some strategies for generating the ID value. ID will be automatically generated. You no need to manually assign the ID for the entity. While entity is getting persisted or stored into the database, during that time only what is also getting generated automatically, ID will be generated. ID will be automatically generated whenever you are setting the or whenever you are saving the entity into the database, while persisting the entity into database. Who will generate that ID? JPA only will do that. System means JPA. For that, what JPA has given some concept called ID generators. Just you need to configure. Okay, there are multiple. JPA has provided multiple generators, and you need to configure which generator you want for generating the ID value. That you need to configure. That you need to add. That's it. Then who will automatically take care of generating the ID for these entities? JPA will do that. There are some strategies are given. They are called ID generator strategies. One strategy is called generation type dot. Generation type is an enum. This enum has constants. Generation type is one enum class. Enums are also can be called as classes, no problem. So generation type is called one enum class. It contains some constants. And you know about enum. Our order status also one enum class only in the last example. Generation type dot identity. Generation type dot sequence. Okay. Generation type dot auto. Next one. In generation type dot table. Last one. Generation type dot UUID. These are called ID generators of JPA. Okay, each one has its own working style. But basically, what is the use of all these generation types? They will generate ID value for an entity while persisting that entity in the database. Each one will follow a different strategy for generating the ID value. All of them will generate ID values only, but each one will follow their own strategy. Okay, right? Suppose I'll tell you how each one is working. Okay. That's what the meaning of what strategy, right? Strategy is a very common word. Alright. Am I right or not? Strategy is a very common word, right? Strategy is. How can I explain you strategy? Very good. Cricket is example. Okay. Each team, each player will follow some strategy. Okay. They have some strategy, right? Okay. Sometimes they will attack. Sometimes they will try to defend. We need to see whether India will reach to semi-final or not. Okay. That will be decided today with Zimbabwe. Okay. So what is your opinion? India will reach to semi-final or not? Answer: India will reach to semi-finals. Okay, right, good. After reaching semi-final, then I'll tell you who will reach to final. Okay, good. Back to the point. Generation type dot identity. Okay, so don't worry, don't keep that burden on your brain. Okay, leave about it. Don't worry, India will reach semi-final. Okay, come back to the point now. Generation type dot identity. Generation type dot sequence. Generation type dot auto. Generation type dot table. Generation type dot what? UUID. Okay. So these are the different generation strategies are available. Sorry. Now, each one will follow a different strategy, right? For example, if you talk about what identity, it will follow one strategy. What strategy? It will use auto increment feature of database. When you're a generation type dot identity, it uses what? Auto increment feature of database for generating the ID for the entity when you are persisting the entity database. You know, at the time of creating a table, you can also make a column as auto increment column. Auto increment feature works for MySQL but doesn't work for Oracle. Remember, it is database dependent. For example, I tell you limit feature works with MySQL but does not work with Oracle. Okay, right? Similarly, auto increment feature works with MySQL but does not work with Oracle. So when you're at generation type dot identity, okay, I'll show you the example. Okay, let us take an example and then we are trying to discuss about each of the features. First one is what? Identity. What happens with identity now? auto increment feature of database will be used by JPA for generating the ID for the entity while persisting the entity in the database. Which feature it is using? Auto increment feature of database for generating the ID value. When you're a generation type dot identity. But identity does not work with Oracle. It works with MySQL but does not work with Oracle. Because it does not have any auto increment feature in the database. You can't make any column like auto increment column. Am I right now? That's called generation type dot identity. Okay. For example, generation type dot sequence. Then JPA will use. Sequence is also an object in database. So JPA will retrieve, select the next value of the sequence object. Will get the next value of a sequence object. Sequence in a database is basically used for generating sequence of numbers, sequence of values. Sequence also an object in the database, like a table, okay, procedure, function. Similarly, sequence, view, synonym, trigger, these are all called what? Objects. What objects? Database objects. These are all called what objects? Database objects. What are the database objects? Tables, table, procedures, functions, triggers, sequence, synonym, view, cursor. These are all what? Objects. What objects? Database objects. Okay. If you're a generation type dot sequence, then what? JPA will fetch retrieve the next value of the sequence. From a sequence it will get the next value. That value will be set for ID and then will persist it in the database. Means store it in the database. The entity gets stored. Means the entity ID generated from sequence. Again, sequence also database dependent. What does it mean? It works for one database but does not work for other. For example, take MySQL. In MySQL, we don't have any sequence. You cannot create a sequence in MySQL. Okay, right? In MySQL, you can create what? Tables. You can create what? Views. You can create what? Procedures. You can create what? Functions. That's it. That's it. You can't create a trigger or you can't create a cursor. Those things are not available in MySQL. Available. But when they are available, if you are working with the MySQL commercial product. What product? Commercial product. But what type of product we are working in the class? It is a open source. Community means free. In a freeware, we don't have all these objects. Only what are there? Tables, procedures, functions, views. That's it. That's why when you open MySQL Workbench, you can observe this. Okay, you open MySQL Workbench. I'll show you today and we will complete all this. You can see here. Okay, test is our database now. If we expand the test, what are visible to you? Tables, views, stored procedures means procedures. Next one, functions. 1, 2, 3, 4. Only 4. Are you finding anything like sequence? Are you finding anything like synonyms? No. Means in this MySQL community version, only what are the database objects supported? Tables, views, procedures, functions. But you don't have any triggers, you don't have any cursors, you don't have any sequence. You got my point now? Do you have any sequence in this list now? No, we don't have any sequence in this list. Very good. So sequence is also database dependent. Sequence is also what? Database dependent. It does not work for MySQL, but it works for Oracle, because in Oracle you can create a sequence object. It works for Oracle but does not work for MySQL. Both are opposite now. Identity works for MySQL but does not work for Oracle. Sequence works for Oracle but does not work for MySQL. What happens if I use it for MySQL? I'll show you that. When I read generation type dot sequence, and when I'm working with MySQL, since a sequence object is not supported, then JPA will do alternate. Alternate in the sense, it creates one sequence table. What table? Sequence table. One table is created called Hibernate underscore sequence. One table gets created. Because table is supported, na? What is supported? Table. Table is supported. Tables are there in MySQL, but what is not there? Sequence is not there. So what happens when you write generation type dot sequence? It creates a table, a sequence table. What is that? Sequence table. Let me show you how to use that, okay? First, to understand all this, I'll explain one by one. But to understand all this, we need example. Just, we create a new example for testing these ID generators, okay? So let's start creating the new example. Very new example we'll start so that we can understand them. So here, project metadata in.ashok IT, and you know these things, right? Let me complete this. Okay, ID generator. I want to give the package name as app, in.ashokit.app. Description, whatever you want, you can write. Properties, jar, 21 version. Coming to dependencies. JPA dependency, MySQL driver dependency, Lombok dependency. What dependency? Lombok dependency. Then you click on generate. So we are done. Let's open this. In IntelliJ, we are going to open this. Let's start opening this application here. Okay, we want to open this application. We want to complete this ID generators concept. Okay, so for that, I am going to open our application. Then we want to test it. Okay. First, we are going to start with identity. Okay, I am just going to create one new package in.ashokit.app.entity. What's the new package I am creating? in.ashokit.app.entity. In this entity, what do we want to create now? One new Java class we are creating. What's the new Java class we are creating? Student. What's the Java class name? Student. This is the entity class. Sure. At entity, Next one is what? At a table. Table name is also student only. Table name and entity class name. If the entity class name is same as the database table name, then tell me at the table annotation is mandatory or optional? Optional. So I can avoid this. Just what is enough now? At entity is enough. Next, we'll add annotations like Lombok annotations. We'll add them later. First of all, this is ID, private integer student ID. Next one, private string student name. Next one is private double student marks. Okay. Look at this now. So I want to add some annotations here. What annotations I want to add? At the rate no args constructor, all args constructor, at the rate data. Now we are discussing about what? ID generator. You need to have some annotations here. Okay. There is an annotation available called at the rate generated value. What is the annotation? At the rate generated value. It has strategy. It has what? Strategy. One element called strategy. Strategy is equal to generation type dot. What is it? Generation type dot. Which one I am selecting? Identity. I told you how many strategies you can find here? 5. Who are the 5? Auto, identity, sequence, table, UUID. Which one I am exploring today first? Identity. Generation type dot identity. Okay. So this annotation at generated value. This annotation, okay, tells or assigns a generation strategy to this ID. So that's why we need to use this annotation along with what? ID. We have to use this annotation generated value with a combination of what? ID. With the combination of ID, we should add one annotation called what? At the rate generated value. Okay, right. What is the purpose of this annotation? It is to configure the ID generator strategy. What is the ID generator strategy that we have configured with this annotation? Generation type dot identity. Okay, I'll show you. Once it is done, we also want to create one interface, or first we'll create a package better. What's the package I'm creating is repository. What's the package? Repository. in.ashokit.app.repository. Entity is okay. What's the next one? Repository. Create a new interface. Create a new interface. For example, interface name is what? Student repository. What is the name? Student repository. Student repository extends JPA repository. Student comma integer. You know why I am writing all these things, right? First one is entity class. Who is entity class? Student. And I don't want to add any custom methods here. Means I am not talking about again query approach. enough find by id, find all, these are enough for me. Save. I don't want any custom methods in this interface. That already we have discussed it. So I don't want anything. Just empty repository interface I'm creating manually. Nice. Now let's create a runner component. Now we are creating, what type of component we are creating? We are creating a runner component. in.ashoka.it.app.runner. New Java class. My runner. What's the class name? My runner. This class implements this class implements what? Application runner.